Let's jump right into it. Welcome to The Explainer. Today, we're taking a pretty wild ride through the evolution of robots. We're going to track how these things literally stepped out of science fiction and completely integrated into our modern reality. Even if, they do still get stuck under the couch sometimes. We're talking about the massive leap from clunky remote-controlled mechanical arms to the hyper-smart machines currently running around our hospitals, our homes, and literally other planets. And, arguably the most important part, we're going to unpack those century-old ethical rules that still bind this whole operation together.
So here's the roadmap for our century-long journey today. We'll kick things off with fiction to factory floors, roll right into the dawn of AI, check out space, cobots, and humanoids, see where things stand with robots in everyday life, and wrap it all up with the 3 laws. All right, let's dive into this.
Part 1. Fiction to factory floors.
So we're rewinding the clock all the way back to the 1920s. This is really where the absolute beginning of robotics takes shape. And it's honestly fascinating because these machines were dreamt up purely to solve human problems, way before the technology even existed to actually build them. But hey, before we talk about the hardware itself, I've got a quick trivia question for you. Where do you think the word robot actually came from? You'd probably assume it was coined by, an engineer in a lab somewhere or maybe a computer scientist, right?
Well, actually, the truth is incredibly theatrical. The term robot was first dropped in the 1920s by a playwright named Karl Kopek in his play called RUR. That stands for Rossum's Universal Robots. That play effectively kickstarted the whole cultural obsession with robots as intelligent, autonomous machines. Back then, robots were strictly fictional, just literary concepts confined to a stage. They literally had to be dreamed up by artists first before they could step out into the real world and become physical, engineered reality.
And man, once that idea was out there, the engineering caught up fast. The early mechanical era moved at breakneck speed. In the 1920s, one of the earliest practical devices was the teletactor, which was this remote-controlled aid designed specifically to help people with disabilities. By the 1930s, the Unimate was in development, laying the groundwork for industrial bots. Then, fast forward to the 1940s and World War II, and robots started taking on super dangerous military work. Things like bomb disposal and surveillance. By the 1950s, those early industrial concepts really matured, and that Unimate system actually started automating the assembly lines over at General Motors.
When you look back at those early heavy-duty machines, the design was purely industrial. It definitely wasn't some walking, talking humanoid. We're talking about a massive, bulky, single-task robotic arm. It was built for one thing: automating industry. Taking over all those brutal, repetitive, and super dangerous jobs like die casting and spot welding. It was mechanical muscle, pure and simple.
Moving on to Part 2, the dawn of AI.
Because pure mechanical muscle, that was just Chapter 1. Shifting into the 1950s and 60s, heavy mechanics finally collided with this groundbreaking new concept called artificial intelligence. Enter Shaky. Developed by the Stanford Research Institute, Shaky is widely considered the absolute first AI-integrated robot. Before this creation, researchers just focused on giving machines more strength, but with AI in the mix, they started exploring the massive, game-changing potential of creating robots that could actually mimic human intelligence. Perception, problem-solving, the whole shebang. Shaky totally opened the floodgates for a hyper-accelerated digital era. Throughout the 1960s, electronic advancements gave us robots that could be programmed for a whole bunch of specific tasks. Then, 1973 hit us with a massive leap, the very first microprocessor-controlled robot, which meant incredibly precise control over movements. By the 80s and 90s, we were building robots with computer vision and real sensory capabilities. They could actually perceive their environment and make decisions on the fly. This massive jump in capability gave birth to the flexible manufacturing system. Suddenly, these sophisticated machines could juggle a variety of tasks on a single production line, making them absolute superstars across the automotive and electronics industries.
All right, Part 3, space, cobots, and humanoids.
From the factory floors, the sky literally became the limit. Going into the 1990s and 2000s, technological evolution just hit the gas pedal, largely fueled by insanely fast advancements in microprocessors, computer vision, and eventually deep learning. With autonomous vehicles entering the chat, exploration leveled up big time. Space probes like the Mars rovers, Spirit and Opportunity, were deployed, which was a staggering milestone in the history of space expedition. We weren't just automating cars anymore, folks. We were autonomously exploring the surface of Mars.
Meanwhile, back down on Earth, the physical design of robots was going through a radical transformation of its own. Think about the staggering contrast between those early designs and what we have now. On one hand, you had early, clunky, four-legged prototypes developed for the military, super rigid, purely functional stuff. But then you compare that to a modern humanoid like Atlas. As we pushed into the 2020s, robots became incredibly versatile. Creating these sleek, dynamic humanoids like Atlas and Asimo, that is an unbelievable leap in engineering. We went from stiff, lumbering machines to highly agile systems that can actually navigate complex, human-centric environments.
Which brings us to Part 4, Robots in Everyday Life.
And that drops us squarely into the present day. Robotics is definitely not just for deep space or heavy manufacturing lines anymore. Today, these things are everywhere in our daily lives. In healthcare, they're assisting in major operations and even offering patient hospitality. Out in agriculture and logistics, they're literally managing our crops and supply chains. And a massive development lately is the rise of cobots, collaborative robots built to work safely right alongside humans on the floor instead of being locked behind safety cages. At home, vacuuming is outsourced to the Roomba, the lawn gets trimmed by a bot. We've even got autonomous food delivery bots rolling down our sidewalks and hyper-advanced social humanoids like Sophia from Hanson Robotics interacting with people and actually holding conversations.
Finally, Part 5, the 3 laws.
Let's see how all this builds into the final, and honestly, maybe the most crucial piece of this giant puzzle, the ethical framework. Because if machines are getting this capable, how do we make sure they stay safe? Well, to get the ethics, we have to look at the core goal of the field itself. Modern robotics is defined as the intersection of science, engineering, and technology dealing with the design and operation of these machines. But the most important part is the end of that definition, to develop intelligent machines that aid humans in diverse ways. Did you catch the keyword aid? The absolute prime directive of all robotics is to help, never to harm.
But here's the wild part. The actual ethical system governing all of this didn't come from some modern Silicon Valley boardroom. Nope. It came from a short science fiction play called Runaround, written by the legendary sci-fi author Isaac Asimov. Asimov effectively laid down the ethical framework for both humans and robots. He created the baseline for modern-day robotics ethics. The top-tier scientists and engineers are literally still referencing today.
So, the crucial point here is the strict hierarchy of these rules. You probably know them as the 3 laws of robotics, and they're designed to operate in a very specific, descending order of importance. Number 1, prevent harm to humans. Number 2, obey human orders. And number 3, protect the robot's own existence. Let's really look at the dramatic weight of each of these.
The first law is the absolute bedrock of the whole system. A robot may not injure a human being or, through inaction, allow a human being to come to harm. Every single thing a robot does has to be filtered through this lens first. Human safety is the undeniable priority, so a robot cannot actively hurt you, and it also can't just stand there and watch you get hurt if it actually has the power to step in and stop it.
Right beneath that is the second law. A robot must obey orders given to it by human beings, except where such orders would conflict with the first law. This is such a brilliantly designed failsafe. It basically means the machine has to do what we say, sure, but it can never be ordered by some bad actor to break that primary rule of human safety. If someone tells a robot to harm another person, the robot's programming fundamentally forces it to refuse that order.
And bringing up the rear, we have the third law. A robot must protect its own existence as long as such protection does not conflict with the first or second law. This makes sure the machine will try to survive and avoid getting destroyed, which, let's be real, makes a lot of sense from a financial standpoint. But the key takeaway is that the machine's own survival is at the very bottom of the list. It will happily sacrifice itself to obey a human command, and it will zero hesitation destroy itself if it means saving a human life.
Which leaves us with a totally fascinating and honestly a slightly daunting thought to end on. We've watched robots evolve from Karl Kappek's theatrical imagination back in the 20s to the Mars rover, all the way up to incredibly complex social humanoids like Sophia today. But as these machines cross into the realm of advanced deep learning and unprecedented artificial intelligence, we really have to ask ourselves, are a century-old set of rules, dreamed up in a fictional sci-fi story, truly enough to govern the hyper-advanced reality we're building? It's a massive question, and it's one the brightest minds in robotics are still wrestling with right now. Hey, keep your eyes on the future, because it is moving faster than ever.